Hello and welcome to another video of Wise Interactive Learning. In this video we are going to see what is the derivative or the derivatives of different inverse trigonometric functions. What do I mean by inverse trigonometric functions? There are basically 6 inverse trigonometric functions, namely sine inverse of x, cos inverse of x and so on, tan, cot, cosec and sec. But in order to understand these different identities of formulas, we just need to look for two particular bunches and we can easily crack onto these formulas just by looking at this simple table which is given on the screen. So first is sine inverse of f of x. So these are the formulas for the composite functions. We are going to just simplify them, but we are going to see that there is similarity between sine and cos, there is similarity between tan and cot, and similarly we have sec and cosec. They have some kind of similarities and you just have to carefully watch what is the similarity between them. So before going on to the composite, I'll give the plain simple formulas, which is sine inverse of x. So if you differentiate it, you are going to get the answer as 1 upon under root of 1 minus x square. So this is your answer. Now when you differentiate cos inverse of x, you have just a negative sign and the whole term is as it is as sine inverse of x, which is 1 upon root of 1 minus x square. Okay, so next we have tan. So we have tan inverse of x and the answer for this is 1 upon 1 plus x square. Now you need to watch carefully what is happening over here. So the cot inverse of x is necessarily negative of 1 upon 1 plus x square. So you can see some similarities that when you understand the formula for sine, you automatically get an idea what is the formula for cos. Similarly, when you know what is tan inverse of x derivative, you automatically know what is cot inverse of x. In the same manner, we have sec inverse of x derivative. So the answer for sec inverse of it is 1 upon x times under root of x square minus 1. And in the same way, for the cosec formula, we have cosec inverse of x. It is given as negative of 1 upon under root of x times x square minus 1. So now how do you remember it and why have I given them in bunches? So if you see that I have given each term in bunches and they are given in pair. So if you remember sine inverse of x derivative, you can automatically remember cos inverse of x. But just to frame inside your brain how to understand them, you can have a common term and which is also this c. So if you look at the c terms, which is cos, cot and cosec, they all have a common thing, which is the negative sign over here, which is the negative sign on the all terms. So now we have two different questions and we have another third question, but we are going to see how they can be solved and what is the main purpose of it. So clearly this question is very easy and it is of the form cos inverse of f of x, and we have a straight formula for this, which is nothing but minus 1 under root of 1 minus f of x square. So here f of x is 4 under root x, so we can directly square it. It will be 16x times. Now we have to differentiate 4 root x. Be careful over here, you can get some things wrong over here. So when you are going to differentiate 4 root x, you can write 4 as it is since it's a constant, and then it will be 1 upon 2 root x. So differentiation of root x is nothing but 1 upon 2 root x. So here is another term which you can simplify, which is 2 and 4 gets cancelled for 2. So your final answer can be minus 2 over these terms, but we are just going for simplification purpose and we are going to take that x and multiply it by 1 minus 16x. So your final answer will be x minus 16x squared. So within 1 to 2 steps we have got your answer. So the next question will be sine inverse of x square minus 1. So this is also of the straight formula which comes like sine inverse of f of x. So it's straightforward, just we have to substitute f of x as x square. So your answer will be 1 upon under root of 1 minus x squared. So f of x squared. So f of x over here is x square minus 1 and whole squared times f dash of x will be 2x. So here's your answer. For this we can simplify this further, where we can say that x square minus 1 whole squared shall be x raised to 4 minus 2x square plus 1. And if you see there's a negative sign over here, so it will mean that 1 minus this whole term shall be, rather we can say this as 1 minus x raised to 4 plus 2x squared minus 1. So this 1 and 1 gets cancelled, and for the final term we have 2x squared minus x raised to 4, and then we can have x squared commoned out. So you have 2 minus x square. So why do we have commoned out over here? Since we have a root on the outside, we can take that out. So your final answer would turn up something like this. So 1 upon, so since we have an under root, we can take that under root and take two different terms. So you can clearly see what I have done. I have taken this term as a different term, as this term or rather this function as different, so we can cancel out all the roots. So x squared under root is nothing but x, and then you have 2x over here. So you can clearly see that this x and this x will get cancelled, and the final answer will be 2 upon root of 2 minus x squared. Now we'll see the third question, which is nothing but some kind of a product rule, where you can say that f raised to x, you can say it as u, and sec inverse of 2x you can state it as v. So clearly the first function is of a form a raised to x, and second is of the form sec inverse of f of x. We have learned all these types of examples, and we are just going to apply all the previous knowledge in such a way that we can easily solve these questions. So the derivative of u times v, or rather the product rule, is nothing but u v dash, which is the derivative of v, and then we have v as constant and again u dash. So this is your plain simple answer to this particular question, but we are going to see what is u dash and v dash in a bit. So instead of going directly, we can individually take u and v and their derivatives. Like we can take u equals to 5 raised to x, and u dash will be automatically 5 raised to x times log of 5, and also we can take v equals to sec inverse of 5x, so sorry, sec inverse of 2x. So immediately v dash of x will become 1 upon 2x under root of 4x square minus 1 times 2. So the answer will be 2 will get cancelled, so it is 1 upon x under root of 4x square minus 1. So you can just put all these values in one term, and there you have your answer, which is nothing but derivative of 5 raised to x time sec inverse of 2x. So I'll just drag it over here, will be nothing but u v dash. So u is nothing but 5 raised to x, v dash is nothing but this term 1 upon x under root 4x square minus 1 plus v, which is sec inverse of x 2x, sec inverse of 2x times 5 raised to x log of a, which is log of 5, which comes from here. So v u dash comes from here and u v dash comes from there. So in these two terms we have 5 raised to x as common, so we can take that out, and your final answer can be defined as 5 raised to x in common, 1 divided by x under root 4x squared minus 1 plus sec inverse of 2x times log of 5. So this is your final answer.